Okay, biology students, so let me talk you through what we did today. First off, we went through our three phenomenon. And the first one is a small petri dish of watery like solution. One of those petri dishes didn't burn and one of them did. You can actually see it here on fire. The question is why? Why would two liquids that look just like each other, seem to have very similar properties, behave so differently? And you actually know quite a few of those answers. The next is going to be this big bodybuilder. That bodybuilder is a pro level bodybuilder who's a vegan, which means he does not eat any animal product, no meat. And so the question is, how exactly is it that this bodybuilder can do exactly that? How can he get all the energy that he needs, all the materials that he needs, and not eat other animal muscle? And then that last little picture down below our flaming petri dish and our bodybuilder is of a burrito. And so the prompt for that one is simply hot burrito or cold burrito. Both of them actually give you the exact same amount of usable energy. And to that I'm asking you, how come? How? So then we went ahead and got back into our notebooks. We added those questions or those very specific prompts in here on the bottom of page 15. And so I'd like you to do exactly the same. Make certain that you've got some kind of graphic that represents each of these three phenomenon and that you've captured the question or the idea behind each. These will eventually be the three essays that I'm going to ask you to write on your unit assessment. After we did that, then we went ahead and we started building some models. We took a look at our previous work. We had done some really nice drawings, and then we had made some models using our ball and stick materials. And so I asked students to go ahead and make me a ethanol model and 3 oxygen gases. So we noticed that our ethanol did burn in the presence of oxygen. And so I gave you the ratio. For 1 atom of ethanol, we called these our little ethanol dogs because they kind of look like 2 legs in the back, 2 legs in the front, a tail, a head, and a nose. But I gave you the formula that this ethanol will burn in the presence of 3 oxygens. So 1 ethanol to 3 oxygens is what it takes. We, of course, had hundreds of thousands, if not millions, of molecules of these accessible when we lit our petri dish on fire. But what we did was we represented these models very specifically in our notebook. I gave you a small placemat with reactants and products, and you built this. Now, this dog has got some pipe cleaners on him. And the reason why is because I asked you to make certain that you understood where, looks like this dog is lifting his leg, where the high energy bonds are on an ethanol molecule. There are 6 of them. 1 on each of the 4 legs, 1 on the tail, and then 1 between the 2 body carbons. So remember, high energy bonds are carbon-carbon and carbon-hydrogen. That's what allows ethanol to burn in the presence of these oxygens. These oxygens don't have any twist ties on them because they don't have any carbon-carbon or carbon-hydrogen bonds. So we set this up in our notebook, and that looked like this. We wrote our reactants, we represented our twist ties with these little red markers, and then we went ahead and counted or accounted for all of our atoms. So we came down here and we made certain that we had total number of molecules. There were 4 molecules there. 1, 2, 3, 4 molecules. And then below the dash, we made certain that we knew all of the atoms and how many atoms of each element there were. So we have 2 carbons, 7 oxygens, 6 hydrogens for a total of 15 atoms in our reactants. We also had these little laminated cards that reminded us early on when you've just got your ethanol dog and your oxygen, that's stored energy. These twist ties are representing stored energy, energy that could be used if the circumstance is right. So we made certain that we captured that over here on the bottom of our page. That energy is 6 little twist ties, and it was stored chemical energy. And then I asked you to pretend to light your ethanol dog on fire, which meant take all these pieces apart. Take all of your oxygens apart, take all of your hydrogens, carbons, and oxygens apart, remove all your twist ties, and then take all of these 15 atoms and see how many carbon dioxides and waters you could buy. Excuse me, not buy, build. And as it turns out, you could make 3 waters and you could make 2 carbon dioxides. So that was super important. Again, still 15 atoms and 14 bonds, but you made 5 new molecules from your burnt up ethanol and oxygen gas. So we then went ahead and we documented that in our products side. So what were produced? What did we end with? When that combustion or that burning or that reaction was happening, we ended up getting carbon dioxide, 2 of them, and 3 water molecules. So that's what we documented next. Then we went back through and we counted how many molecules total. This time we had 5. And then do we have conservation of atoms? We had 2 before, we still have 2. We had 7 atoms of oxygen before, we still have 7 now, and we still have 6 hydrogen, which is still a total of 15 atoms total. However, now there's not a single twist tie in the mix. Not 1 carbon-carbon, nor 1 carbon-hydrogen. And the reason why was because those twist ties were released and you saw them transform from stored energy into light, motion, and heat. So light, motion, and heat is what's happened to our energy. It went from stored energy, then it got transformed to heat, motion, and light. So that's really important that you get those details. So this evening, or not this evening, this weekend at some point, what I'm asking you to do is to make certain that you add some of the details, take care of some color work. I made certain that you knew reactants were what we start with, yields means to make, and products are what you end up with. I made sure that you knew that my twist ties were bonds that were representing high energy. And then I wanted to make certain you understood atoms are never created or destroyed. So there's our atoms, 15 at the beginning, 15 at the end. That's what this means. It has to be equal. And that energy also cannot be created nor destroyed. It's just transformed from one type, like stored chemical potential energy, to another type, heat, motion, and light. Please make certain that you've got that synced up. Make sure that you've got your images and a little bit of color work down here, and that you review and have a beautiful weekend. See you on Monday.